Good morning, students. I'm Shantini Datta. Today, I'll discuss the chapter Magnet. So, the topic that we are going to discuss in this chapter are magnetic substance, non magnetic substance, natural magnet, artificial magnet, properties of magnet, dielectric property, attractive property. Each magnet has two poles. A magnet can induce magnetism. Repulsion test is a Shearer test. Loss of magnetism of a magnet, features of a magnet, and electromagnet. So the first topic is magnetic substance. The substance which are strongly attracted by magnet are called magnetic substance. For example, iron, cobalt, nickel, and their alloys. In the diagram, you can see an examples of the magnetic materials are given there. Nickel knife, cobalt coin, steel spoon, iron nail, steel paper clip, etc. So what are non-magnetic substances? Those materials which do not attract by a magnet are called non-magnetic substance. Example, plastic, rubber, water, etc. There are two types of magnets, natural magnet and artificial magnet. Natural magnets are those which are made in nature, and artificial magnets are those which are made by humans. So what is natural magnet? So natural magnet is a magnet which are available in nature, number one. Number two, it has the property of attracting iron, and these are weak magnets. Next is that what are artificial magnets? So artificial magnets are strong magnets. They are made by humans and they are available in different shapes and sizes. So the next topic is properties of magnet. Attractive property, directive property. Magnet has two poles. Like poles repel and unlike poles attract. Induce magnetism and loss of magnetic property. Attractive property. Magnet has a property to attract magnetic substances. So the next property is directive property. Magnets are used to show directions. If I take a freely suspended magnet, it will always rest in the north-south pole, which means the north pole will always rest towards the geographical north and the south pole will always rest towards geographical south. Now we all know about a device called a magnetic compass, which is used to show directions. Each magnet has two poles. Single pole cannot exist. Every magnet has north pole and south pole. Now if I take one magnet and I break it from the middle, then we'll see in the both the parts, north pole and south pole is generated. Now if I keep breaking a magnet in half, I'll find that every time I break the magnet, north pole and south pole is created. So isolated poles does not exist. So the next property, we all know it. Unlike poles attract each other and like poles repel each other. As you can see in this diagram given, North Pole and South Pole both are unlike poles and they are attracting each other, whereas North Pole and North Pole are both are like poles, they are repelling each other. Then again, the South Pole and South Pole both are repelling each other. A magnet can induce magnetism. What does it mean? Suppose I take a unmagnetized material and brought it near or touch it with a permanent magnet. Then this unmagnetized material becomes magnet. You can see in the diagram over here, the iron nail, the person holding the iron nail, this iron nail is an unmagnetized material. This unmagnetized material cannot attract the another iron nail which is on the ground as shown in the diagram. The second diagram showing that a bar magnet is brought near this iron nail, and this iron nail now gets attracted to the magnet, and it also attracts the second iron nail, which shows that this first iron nail is magnetized. So this property is known as induced magnetism. So the next property is loss of magnetic property. When magnet is heated, its magnetic property is lost. The minimum temperature at which the magnetic property is lost is called Curie's point. So the next topic is repulsion is a surer test. Now, a magnet can attract as well as it can repel. Now, the question is that why is repulsion is a surer test? How come we come to know that if two magnets, there is a repulsion between the two magnets, then that is a magnet. The reason behind is attraction can be caused either by the opposite poles of the magnet or between one pole of the magnet and an unmagnetized material. So if I take two poles of a magnet can attract also, and a magnet and an unmagnetized material can also attract. But repulsion is only possible when there is two similar poles of magnet. Thereby, repulsion is the surer test of magnetism. Okay, so the next topic is features of magnet. First over here, we'll study magnetic length. What is magnetic length? The distance between the two poles, that is the North Pole and the South Pole, is known as magnetic length, right? And what is geometric length? The actual length of the magnet is called geometric length. So geometric length is always bigger than the magnetic length. Magnetic length is equal to 0.86 into geometrical length. The attracting power of a magnet is maximum at the two poles, and it is zero in the middle part of the magnet, which is also known as neutral zone. Electromagnet. What is electromagnet? An electromagnet is a temporary magnet, and you can make this magnet by passing electric current through an insulated copper wire coiled around a soft iron body. Now, what does it actually mean? You can do this experiment by at home. Suppose you want to make a magnet and you have iron nail, battery, and wire. By this, you can make an electromagnet. What you will do it? You take an iron nail, you wind this copper wire and connect it with the battery. Once the key is on and the current flows through the coil, then this iron nail behaves as a magnet, right? This is known as electromagnet. Now, electromagnet, you can increase the magnetic property or you can increase its strength by just increasing the battery or by increasing the number of turns. In an electromagnet, if the direction of the current is clockwise, then it is a south pole, and if it is anti-clockwise, then it is a north pole. Use of electromagnets. Electromagnets are used in lifting heavy loads. It is used in electric bell. It is used in loudspeaker. Thank you.